Getting high-quality digital designs to market quickly means taking advantage of the latest technology. System-on-chip architectures and FPGAs are at the forefront of technology advances in electronics. While big and fast FPGAs enable new levels of sophistication, they present integration challenges best addressed with real-time measurements. What if you could measure real-time behavior inside of your FPGA? What if you could easily access a large number of signals through a small number of pins? What if measuring new groups of internal signals never required a design change or FPGA recompile? Oscilloscopes have long been the tool of choice for gaining insight into your FPGA and the surrounding system. What if these on-chip measurements were automatically integrated with your MSO? Agilent and Altera have developed an innovative approach for increasing FPGA debug productivity. The FPGA Dynamic Probe is the world's first integrated system for making on-chip measurements with an MSO, and it's compatible with all currently shipping MSOs. The FPGA Dynamic Probe application is composed of three main elements: an Altera FPGA with a special MSO LAI debug core, an Agilent MSO running an FPGA Dynamic Probe software application, or a PC running an FPGA Dynamic Probe application connected via USB or LAN to the MSO, and an Altera cable that provides the physical communication via JTAG. The measurement system starts with the Logic Analyzer Interface Core, or LAI for short. The LAI core is a configurable MUX. The inputs to the MUX connect to groups of internal signals that you specify for measurement with the MSO. The output of the MUX is routed to physical pins on the FPGA for connection to the MSO. A JTAG communication channel provides control of the MUX. FPGA Dynamic Probe application software allows you to control which group of internal signals is visible. Together, these elements create an interactive measurement system that provides internal visibility, access to a large number of signals using a minimum of pins, and dynamic probing of new signals without design changes. With this basic understanding of the system, let's look at implementing a design using the FPGA Dynamic Probe. The process begins with Altera Quartus 2. Set the parameters of the core and specify the groups of signals you need to measure. Using Quartus 2, insert the configured core into your FPGA design. The entire process of creating the core typically takes 15 to 30 minutes. LAI core outputs are routed to FPGA pins physically connected to the MSO. Setting up the mixed signal oscilloscope is done using the FPGA Dynamic Probe application, which is fully integrated with Agilent's MSOs running Windows, or for portable MSOs that don't run Windows, create a USB or a LAN connection between your MSO and PC running the application software. Setting up the measurement on the instrument typically takes about 1 minute. First, create a JTAG communication link to a specific LAI core. Import signal names from your Altera design tools. Next, use graphical pin mapping to specify the physical connection between FPGA pins and MSO channels. Now, with the setup complete, you can interactively change groups of internal signals to be measured in a single mouse click. Simply select the desired signal bank from the selection menu in the application software. The FPGA Dynamic Probe application reconfigures the MUX via the JTAG connection to make the desired signals visible. Synchronizing signal names with each new measurement is handled automatically, so what you see is always presented in terms you understand. When you need to see the operation of another bank of signals, simply select that bank. The MUX is reconfigured, and the signals on the MSO are updated. It's that simple. Limited by a lack of real-time visibility into your FPGA? Frustrated with having to change your design to get access to new internal signals? Tired of manually updating your oscilloscope with signal names from your design? Start saving days to weeks of development time with Agilent's FPGA Dynamic Pro. The application is supported on all currently shipping Agilent MSOs. For more information, visit our websites